let me draw a curve, then you would understand what is the stationary point stands for. Say in a quadratic curve, if we draw a quadratic curve having with the maximum point, the point curve turns, that point is called the stationary point or turning point. Stationary point, this is the stationary point. So having with the maximum, if you draw another quadratic having with the minimum, this point is called the stationary point. That is another point. So in a cubic curve there are 2 points, one with the maximum point, another one is the minimum point. So that 2 point is also called the stationary point because curve turns here. That another name of this point is called the turning point. So without drawing a curve, how to do that, let me show, then hoping that you would understand after seeing my working. So here in that stage the questions is finding the coordinate of the stationary point, the first question, and the second part of the question is determine the nature of the stationary point, means the is it the maximum or minimum, that's we are going to get from here. So let's see the first example. I have wrote here the A, which is written here y equals to, curve equation is x square minus 6x plus 5. To get the coordinate of the stationary point, always we needed to find out the dy by dx first, then we would consider dy by dx equals to 0 to get the value of x of the stationary point. Then that value of x we have to put in the main equation to get the y value. And for determine the stationary point, is it maximum or minimum, nature of the stationary point, we have to differentiate it second time, I mean second derivative of double differentiation. Let me see the total example, then I hope that you would understand. So dy by dx, so let you consider dy by dx first. We got from here 2x minus 6. So if you at the first time you are seeing this differentiation, so there are some simple differentiation topics are there in this channel. So from the top icon, click on the I button and check the other videos for the simple equations are there. So we need to consider dy by dx equals to 0 right now. So let us write the value, twice x minus 6 equals to 0. Then we got the value x equals to 3. So this is the stationary point x value, and now we have to find out the y value because it is written here coordinates. Coordinates means x and y value, both we have to find out. So let me put the value of x here, y equals to 3 square minus 6 into 3 plus 5. So we got from here 9 minus this is the 18 plus 5. So it gives us minus 9 plus 5, which is minus 4. So our stationary point coordinate you can write here 3 minus 4. This is our stationary point. So now we are going to see the nature of the stationary point, determine the nature of each stationary point is written here. So for doing that we have to differentiate second time d square y by dx square. We have the expression 2x minus 6. If I differentiate it again, so we got the value 2 from here, which is a positive value. So after double differentiation, if we get the value directly, say d square y by dx square, if the value is greater than 0, then the point stands for actually stands for the minimum. So according to this equation we can say this is the point we got. So 3, we can write here 3 minus 4 is a minimum point. So this is the total working of this equation. Let's go for the another one. I'm going to show the part B as well. So if I consider the equation B, same working is here. For B we have to differentiate first. Let me differentiate dy by dx. The value we got from here minus 2x plus 2. Now we need to consider 0. for getting the value of x equals to minus 2x equals to minus 2, then x we got from here 1. So now we are going to find out the y value by putting this one in the main equation, minus 1 square plus 2 into minus 1, so it gives us minus 1 minus 2, which is minus 3. So coordinate of the stationary point you can write 1 comma minus 3. Now double differentiation is needed to see whether the point is maximum or minimum. This square by dx square, and we got from here, this is our first derivative expression. So if we differentiate it, we got from here negative 2. So negative 2 is we need to mention here negative value, and if the double differentiation gives us negative value, then we can conclude our answer. The point we got 1 minus 3 is a maximum point. So this is our total working. We also can write d square y by dx square. If we got negative less than 0, then this is the condition. We can say this point is a maximum point. This is the next we consider the question number D from here, another quadratic having with the 2 point. So it is given here y equals to the expression. So first differentiate dy by dx. We got from here 3x square plus 2x minus 16. Now we need to consider dy by dx equals to 0. So 3x square plus 2x minus 16 equals to 0. So let me find out the x value from here. So yeah, we can do it by doing the middle term back. Say 3x square, 6 is the 3, 16, 48. So we can break down 8 and 6 plus 8x minus 6x minus 16. Then from the first part you can take x common, then it gives us 3x plus 8 minus 2 common from the second part, which is gives us 3x plus 8 again. So consider 0. Two factors are there. One is 3x plus 8, another one x minus 2 equals to 0. So 2x values minus 8 by 3, another x value equals to 2. Now for this two particular value gives us two y values. Let me write the equation, and we needed to use calculator now to get our y value. X cube plus x square minus 16x minus 16. This is our equation. Let me use the calculator to get our value here. So for doing that, better to write the equation with the alpha x cube. Let me write the alpha x cube. Then I'm going to write the full equation, plus x square alpha x square minus 16x minus 16 alpha x, then last part is written minus 16. Okay, now for two values we can use. First one is minus 8 by 3. If we put, so we need to press calculate. X value is minus 8 by 3. Let me put the minus 8 by 3, and we got from here 400 by 27. So we can write when x equals to, we can write here when x equals to minus 8 by 3, then you got the y equals to 400 by 7. Then another value when x equals to 2, what is our y value? We need to use again calculator. Let me press calculator again. So 400 by 27. It was 400 by 27. And for the second value we need to press calculate again and calculate 2. It gives us minus 36. So minus 36. So our coordinate we can write 2 comma minus 36, another coordinate, and minus 8 over 3 comma 400 divided by 27. This is the coordinate of this equation. stationary point, turning point or stationary point of this point. Now we are going to check whether this point is maximum or minimum, whatever it is. So in that case we have to differentiate again the expression. Let me isolate this one. D square y by dx square, and double differentiate gives us 6x plus 2. So when x equals to 2, we got double differentiation d square y by dx square, which is 6 into 2 plus 2. So we can write here 12 plus 2 is 14, which is a positive value. Positive value means the point 2 minus 36 is a minimum point. After double differentiation, putting the value of x, if you get the positive, then that value stands for the minimum point. So another part, when x equals to negative 8 by 3, d square y by dx square, double differentiation gives us 6 into minus 8 by 3 plus 2. We needed to use again calculator. Let us 6. So the value of here we have to put, which is 6 into, calculate, 6 into negative 8 over 3, then another part is plus 2, and it gives us minus 14. So let me write minus 14 equals to minus 14, which is a negative value. So we can say this point's minus 8 over 3 comma 400 by 27 is a maximum point. This is the total working of this equation, dy by dx, and second derivative is needed to check whether the point is maximum or minimum. I wrote here some other equation, so I'm keeping this question specially, question number C, question number E, and question number F for doing yourself. Please let you do that 3 question with yourself and write on the comments below. I want to say whether you did it correctly or not. Another questions, I prepared this one for stationary point. It is slightly different. We know the stationary point at 1, 3 is written there. So stationary point, actually we need to consider dy by dx equals to 0. We know dy by dx is 0. In this point 1 by 3, it is dy by dx value is 0. So first we need to differentiate. If we differentiate from here, we got 3x square plus a. Let you consider 0 by putting the value of x equals to 1 here. So we can write here 3 into 1 square plus a equals to 0, and from here we can write here a equals to minus 3. So directly we would get from here a equals to minus 3. And how to find out the value of b from here? Because stationary point 1 and 3, definitely this point lies on that curve, so we can use another part. By putting this point in the main equation, we can get out the value of b from here. The value 0.13 satisfy this equation. So as a y value, you can write as a 3 equals to x value is 1 written, so 1 to the power 3 plus a value we got from here minus 3, put it minus 3, and into another value, x value is 1 plus b. This is our second equation. So you can write it 3 equals to 1 minus 3 plus b. So 6 minus 1 equals to b. Or we can write here b equals to 5. So this is our value of a and b. Now our main equation, let you write the main equation, y equals to x cube, and we got a equals to minus 3x plus 5. This is our curve equation. So the first question, they ask us to find out the a and b. We already have done. Then the second question, determine the nature of the stationary point. For doing that, we have to differentiate it again. We have the first derivative, which is 3x square plus a. So our second derivative is d square y by dx square. We need to differentiate it again, so we got from here 6x. Because a is a constant, it gives us 0. So now put our value, x is 1 written there. Let me put the value. So 6 into 1, 6, which is a positive value. So you can say 1 and 3 is a minimum point. Done. Second part of this question done. This is the working of the second part, and that is the first part working. Now the next question is, find the coordinates of the other stationary point on the curve and determine the nature of the stationary point. Third part of this question. See, for doing that, because we already have the expression of dy by dx actually dy by dx, if I put the value of a here, dy by dx expression is, you can write it 3x square, a value we got minus 3, let me put it here, minus 3, consider equals to 0. So dy by dx equals to 0, we are considering it again to get the another value of x. So from here we got x square equals to 1, which gives us x equals to plus minus 1. I already here one point already given, 1 and 3. Now so another point is, therefore x, we got another point which is minus 1. Now we needed to find out the y value by putting this in the main equation. Minus 1, 3 minus 3 into minus 1 plus 5. From here you can write minus 1 plus 3 plus 5, which is 7. Yeah, 8 minus 1 is 7. So our second coordinate of this equation, which is minus 1 comma 7. Now for checking whether the point is minimum or maximum, we already have the double differentiation, d square y by dx square. We needed to put here the value of x, we got minus 1. This value we are going to put here, x is minus 1, so it gives us minus 6, which is a negative value. So we can say minus 1, 7 is a maximum point. This is the way to do these questions. It's slightly different question. So this that is the total working I prepared for you to show. And like before, I prepared one worksheet for you, which about the stationary point. Some of the questions are there, 1 2 3 4 5 6 questions are there. So that question already has been uploaded in the description below. You are welcome to download it for your practice. And next tutorial we will explain about the maximum and minimum points, how to get the maximum minimum point from the different